Hey, once again, we're computing with scientific notation, and this time we're going to try to tackle addition. And so I have this problem here, 9.67 times 10 to the 6 plus 3.45 times 10 to the 5th. And this time it's not like the multiplication or division. This adding is going to require us to think a little differently here. Before I jump into this though, I want to point out something. It's something we're going to use as part of completing this, but I wanted to do it with some much more straightforward numbers. And to do this, I'm going to make kind of a simpler version of the same kind of problem. So what if we had a problem that looked like this? 2 times 10, or 10 to the first, right? Plus 3 times 10 to the first. Smaller numbers, not as much going on here. I want to remind you of the distributive property, because we're going to use that right now when we come back to this. So if you remember, the distributive property looks for things that are common. If you're given something, what we want to do is we want to factor this. What we're looking for is we're looking for things that are the same. And lo and behold, look, that highlighted color doesn't look very good at all here, does it? But I notice this part is exactly the same as this part, isn't it? And so what I'm going to do is I'm going to rewrite it as follows. I'm going to factor out this 10. So 10, you're going to come out over here. I'm going to write you here. And the rest of it, my 2 plus 3, I'm going to leave inside the parentheses. So what I'm trying to say here is that this problem here and this are the same thing. And if we just kind of looked at some numbers, hopefully it makes sense, because 2 times 10 is 20, 3 times 10 is 30, right? So 20 plus 30 is 50. We can see that. Here, if I used order of operations, 2 plus 3 is 5, and 5 times 10 is 50. We've done this in the past where we looked at this as an area problem. Remember this? We had a rectangle here with the width of 10, and I kind of broke it up into two parts where I told you this length was 2 and this length here was 3 for this piece. Well, I could see that this part here would be 10 times 2 is 20, and this part here would be 10 times 3 is 30. But together you can see the whole area would be 50. Or another way we looked at it was kind of like this. If I started out with my rectangle, and I told you this little area was 20, and I told you this area was 30, and couldn't we break this apart? That's a 2 there, 20. Sure, I could break it apart as 10 wide, and this part here would be 2 plus 3, right? 10 times 2 is 20, 10 times 3 is 30. But I'm left again with my 10 times 2 plus 3, 10 times 5 is 50. So we're going to take advantage of this distributing property here. Hope that wasn't too long of a side draft. And what I'm going to do is I've got two things that are close to each other, but they're not exact. So I need to adjust one of these. So I'm going to make this look like this. So first thing I'm going to do is I'm going to take this 10 to the 6 and write it as 10 to the first power times 10 to the 5th, because those two together, same base, multiplied, it's 10 to the 6. And 9 point, I'm going to fill in the rest here. So I've changed this to look like this, plus 3 4500ths times 10 to the 5th. So what I'm going to do is I'm going to combine these two parts right here. So I have just 10 to the 5th in each piece. So if I multiply this by 10, I'm going to that shifts the decimal point over. I have 96 7/10 times 10 to the 5th. That's going to be plus 3 4500ths times 10 to the 5th. Well, now I do have the same piece here and here. In this, I'm going to factor out. So what does that look like? Well, I'm going to bring this piece out here. It's going to become 10 to the 5th, And that leaves me with those pieces. So it'll look like 96 7/10 plus 3 4500ths. And now it kind of looks like an order of operations problem. That's exactly what we'll do. So I'll bring this part over here just so we can kind of do it neatly. When we add decimals or subtract, we line up the decimal points. So when I add those up, looks like I'm going to have to fill in a 0 here. Right? So 0 and 5 is 5. 7 plus 4 is 11. Put down the 1, carry the 1. 1 and 6 is 7, plus 3 is 10. Carry the 1, and 1 and 9 is 10, okay? And we bring the decimal point straight down when we add, right? Let's put adding here. So inside the parenthesis now I have this. I have 100 decimal 15 hundredths times, because parenthesis means times, 10 to the 5th. Ooh, here, now we're starting to look close to scientific notation. But remember, I have to move my decimal point here. So if I move it this way, I'm actually dividing. I'm making it smaller. I'm dividing it by 10 100. So what I need in dividing, just using our negative exponent rule again. So I'm dividing by 100. All right? So dividing by 100 is going to be similar to this. I'm going to have 1 decimal 0015. I divided by 10. So in order to divide by 10 to return this, I'm going to have to multiply. I said 10, didn't I? I divided by 100 because I went twice. Once, twice. So that's dividing by 100. I'm going to have to multiply 100. And 100 is simply 10 to the 2nd power. Then I bring down this last part here. Times 10 to the 5th power. Ooh, multiply same base, add the exponents. Looks like we're about 2 steps away. So same base, add the exponents. And we're finally at our end here. And there's our answer. Was it a few steps? Yes, but remember, we took the time to go through each step carefully. And remember, what we did here that made it work is we rewrote the base 10 to 1 exponent so that we had 2 that were the same that we were able to factor out. But the remaining parts we kept in the parentheses, and then we just did order of operations. Hope this helps.